Welcome to this explainer. Today, we're measuring the new global power and the technological arms race. Forget about counting tanks or battleships. We're going to completely demystify the global race for technological supremacy, and we're using the brand new Critical and Emerging Technologies Index from the Belfer Center to do it. It's an absolutely fascinating look at exactly how the future is being built, funded, and honestly fought over right now.
So let's dive right in. For centuries, we measured global power by looking at things like military might, geographic control, or just sheer economic output. But today, global power isn't just about how many ships you have in the water. It is fundamentally defined by a nation's ability to build and sustain advanced technological ecosystems. Basically, the nations that control the tech control the future.
And the Belfer Center has effectively created the ultimate scoreboard for this. They analyzed literally millions of data points across 25 different countries to see who is actually leading in the tech that matters most. It's this incredibly detailed quantitative model that benchmarks progress, and what it reveals is that global power is highly concentrated right now, yet constantly shifting beneath our feet.
Now, you might be wondering, what are they actually measuring? Well, we're tracking 5 specific critical and emerging technology sectors: artificial intelligence, biotechnology, semiconductors, space, and quantum. These are the 5 battlegrounds that the US and its allies consider absolutely vital to national security and strategic autonomy, because, as you know, advancements here pretty much drive progress everywhere else in the economy.
Section 1. The US-China Tech Duopoly.
Let's look at the 2 absolute heavyweights dominating this new scoreboard. The crucial point here is that the United States and China lead the pack, for sure, but they do it in completely different ways. The US relies on a decentralized, resource-rich ecosystem, think Silicon Valley startups, university labs, massive private capital, to maintain a really clear lead in AI and space. China, on the other hand, leverages centralized planning, immense state-backed funding, and just a massive scale of data and human capital to rapidly close the gap. And they're doing that especially fast in biotechnology and quantum.
Section 2. Convergence and Supply Choke Points.
The thing is, these sectors do not exist in a vacuum. Technological convergence is very real. Powerful AI models are accelerating drug discovery and biotechnology. Space tech relies completely on advanced semiconductors. Advancements in one sector create network effects that accelerate progress everywhere. That means nations can't just be good at one isolated thing. They actually have to maintain an edge across a whole constellation of technologies to stay relevant. But of course, this interconnectedness also creates highly fragile supply chains.
A perfect example of this fragility is the semiconductor industry. It is wild. Absolutely no country has an end-to-end supply chain. The US designs the chips, but they rely on Taiwan to actually manufacture the most advanced ones. Meanwhile, China handles a massive amount of the legacy manufacturing and assembly, while Japan and the Netherlands supply the highly specific machines needed to print the chips. So global tech power is literally a giant puzzle with missing pieces for everyone. I mean, even an absolute superpower cannot build a modern smartphone entirely from scratch.
And this fragility leads to very real-world geopolitical tension. Take US export controls, designed to limit China's access to advanced tech. They end up impacting the market very unevenly. Because of soaring AI demand, a chip designer like NVIDIA grew immensely, even with restrictions in place. But equipment makers like Applied Materials, they saw much slower growth, simply because their main customers, the fabrication plants, don't buy new equipment nearly as often. It's a fascinating paradox that really highlights how policy hits different parts of the exact same supply chain.
Section 3. Europe and the Rising Stars.
Outside of the US and China, what's really interesting is what happens when you group Europe together. Aggregated as a unified bloc, Europe ranks 3rd globally in AI, biotech, and quantum. By pooling their resources and coordinating through massive initiatives like Horizon Europe and the European Space Agency, Europe manages to remain a highly competitive force. But they absolutely have to act together to even stand a chance competing with the sheer scale of the US and China. The good news for everyone else? You don't actually need a massive economy to wield strategic influence. Smaller players are building incredibly durable advantages just by leaning into their specialized strengths. Japan is pouring massive private capital into biotech and AI robotics. India is executing incredibly complex space missions, and they hold nearly 20% of the world's chip design engineers. Canada, with a tiny fraction of the global population, has somehow secured 5% of all global quantum talent through a focused national strategy. And Australia has built these world-class layered biosecurity systems. It proves a point. Find your niche, and you become indispensable.
Section 4. The Quantum Frontier.
Now let's zoom all the way in on the bleeding-edge frontier that is going to redefine literally everything: quantum technology.
To understand why this is such a game changer, we have to grasp this concept called superposition. In classical computing, data is a 1 or a 0, right? Binary. But in quantum mechanics, particles can exist in multiple configurations simultaneously until they're measured. Think of a coin spinning in the air. It's both heads and tails at the exact same time. This allows quantum processors to pursue optimal computational paths in parallel, all at once. They can solve complex optimization problems that are fundamentally impossible for classical machines to crack.
Just to put this mind-bending reality into perspective, Google recently unveiled their new Willow quantum chip. They gave it a highly complex mathematical benchmark. Now, the world's absolute fastest traditional supercomputer. It would take 10 septillion years to solve it. That is longer than the universe has even existed. Google's Willow chip did it in 5 minutes. Just let that sink in for a second. 5 minutes versus 10 septillion years. No way a normal computer competes with that.
And we are already seeing the real-world application of this breakthrough. Researchers at King's College London just gained access to that exact Google Willow chip specifically to model atomic-level natural systems, like photosynthesis. Because natural processes rely on fundamental particle interactions, they are just way too complex for normal computers. But with quantum, researchers believe they could develop revolutionary solar cells, perfectly efficient energy grids, and even cures for currently untreatable diseases as early as 2030.
But despite its magic, quantum remains a very early-stage frontier. It's heavily dependent on economic resources and human capital from the top 3 global players. The US, China, and Europe have all invested roughly $9 to $10 billion into quantum research. China actually leads pretty heavily in quantum sensing and communications, while the US pushes really hard on the computing side. It's an incredibly tight, 3-way race to master the physics of the universe.
Section 5. Who wins the future? So who actually wins this ongoing geopolitical showdown? Well, as the Belfer Center report perfectly summarizes, the winner will be the nation that best nurtures its human capital and economic resources. You just can't buy your way to the top. You have to actively build and sustain a decentralized, adaptable innovation ecosystem. That requires brilliant researchers, daring private investment, and supportive public policy, all working in tandem.
But I want to leave you with this final, kind of unsettling thought. As we hurtle toward this new frontier, we face a massive paradox. The exact same quantum systems that will perfectly model photosynthesis and cure diseases by 2030, they will also possess the computational power to break literally every piece of global encryption currently safeguarding our financial grids and our private communications. So we really have to ask ourselves, as this technological arms race accelerates, does wielding this unimaginable power make our world safer or fundamentally more dangerous? Thanks for joining me on this explainer, and keep questioning the future.